Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet. Today's host is Dan Kazwara. He is their field application engineer, and he'll be presenting today. If anyone has any questions, please submit them in the question box, and Dan will answer them at the end of today's presentation. Dan, I am finished for now. Please go ahead and take it on over.
Okay, thank you, Julie, and thank you, Microcom, for having me today. So today, I'll be covering our IgniteNet product line. I want to introduce you to kind of an overview of 60 gigahertz, which is IgniteNet's specialty. We focus on the 60 gigahertz frequency with our radios. Also cover our link path tool, which is our 60 gigahertz tool for measuring links and signal strength for links. Also, just overall 60 gigahertz product line, which is called the Metrolink. IgniteNet switches, the indoor and outdoor Wi-Fi products IgniteNet has, are G-Link Ethernet to coax adapters, and the IgniteNet Cloud. Okay, so first I want to cover a little overview about 60 gigahertz. So 60 gigahertz is part of the V-band, or 40 to 75 gigahertz. It's also coined or termed as the millimeter waves, and the reason why is because the wavelength is in the millimeters. 60 gigahertz is about 5 millimeters, or half a centimeter, so it's very small wavelength, very small. The FCC adopted it, and I'm referring to the FCC United States, as an unlicensed band for 57 to 64 gigahertz back in 2001, and then recently added even more frequency space, 7 more gigahertz of space, for a total of 14 gigahertz. So even if you're outside the US, there's still a lot of frequency space still available. A total of 7 gigahertz is a ton of RF space. Now, compared to, say, some of the other unlicensed frequency bands, and 60 gigahertz is unlicensed. So there's 5 gigahertz, 24 gigahertz. Well, 24 is another millimeter wave unlicensed frequency band. 5, also 2.4, 5 gigahertz ISM band. The thing about 60 gigahertz is it's shorter range. Okay, so then you say, well, that's a bad thing. Well, not necessarily. In other words, each frequency is like a tool, and you use the tool according to the application. So where 5 gigahertz shines in distance, and it goes very far. You can go, 20 plus kilometers. The problem is channel reuse or frequency interference. You have, like, say you're on a tower up at a high elevation site, you might see the entire 5 gigahertz band all tied up. So you're going to get and receive interference pretty far because it propagates far. Where 60 gigahertz is shorter range, and therefore channel reuse is real easy, and the likelihood of getting interference from other stations aside from your own that you set up are virtually zero. So the distances you'll get in 60 gigahertz is a few kilometers, kind of similar to 24, actually. The thing about 24 is that there's not a lot of RF frequency space. You notice there's actually less than 5 gigahertz. So although it is a lower frequency, a little less free space path loss, not a lot of RF space there. The other thing is 24 is particularly susceptible to attenuation from rain or water molecules. Okay, so this slide is showing, see, the distance compared to, say, 5 gigahertz and 2.4 as far as the window of getting or receiving interference. And also I didn't mention the beam width of a typical 60 gigahertz radio or point-to-point is much narrower. So that's another reason for getting less interference or causing less interference. Now, the other factor with 60 gigahertz, I mentioned 24 having water molecule absorption, is that 60 gigahertz has oxygen absorption, which further reduces its range. So it's good for a few kilometers or a few miles, up to about 1.5 miles is what our links typically go to. So most links are 1 mile or less, or 2 kilometers or less. Okay, so the link path tool. So you go to our cloud, www.cloud.ignitenet.com, It's a free, okay, that is free, by the way. You can go online and create an account for free, and you could use our link path tool to calculate for 60 gigahertz. Say in this example, it's showing a 35 centimeter radio. That's a 42 dBi antenna radio. The other one, the client in this case, in this example, would be, well, the slide is showing like an 18 dBi. So, and yes, the channel actually matters for 60 gigahertz, which is another unique thing because oxygen absorption is centered right around 60 gigahertz, which is channel 2. If you're slightly below 60 gigahertz, and if you go above 60 gigahertz, channel 3 and 4, you actually have a better, or I should say, a different signal strength depending on what channel you're on. A couple dB plus or minus. So that's actually a factor, which is kind of unique to 62. It depends on what channel you're on. The signal actually is a little different. Rain is, with all millimeter above 10 gigahertz, you're going to have some rain fade, not as bad as 24, which is particularly attenuative for water, but there is some rain fade, which you should factor in. There's a few dB. And then the power, our output power of our radios are 14 dBm max output power on 60 gigahertz. This example showing a half a kilometer, 500 meters, with no rate of signal expected is a negative 56 dBm. So based on the ITU rain model, depending on what region you're in, would determine how much you should factor in. And you just find out, let's say you're in rain zone A, the calculator expects, if you're in A, to have 8 millimeters per hour of rain. I recommend that when you do this, you do factor in for worst case scenario. You do factor in rain because, you know, it might be a sunny day, but you want to factor for the worst case scenario, not the best case scenario. And also within the link path tool, it kind of gives you an estimate of the kind of expected throughput based on the signal and distance of your link. Okay, so 60 gigahertz, again, I want to cover, there's 4 channels in our radios, channels 1 through 4, and they're 2.16 gigahertz wide, or 2160 megahertz, really wide channels. It was originally based on 802.11ad chipset, and that's why the channels are so wide. Normally wouldn't even need them that wide. So later, actually, and more recently, in our firmware 2.4.1, which was released a few months ago, if you played around with radios, you'll see that there's an option now for half channel. It's still over a gigahertz wide, so it's still really wide. And a lot of times you'll see the available throughput, the gig speed is still maintained, even though it's a half channel. Because say compare it to a 5 gigahertz, 80 megahertz wide channel, right? This is still 10, 12, 15 times wider than an 80 megahertz, you know, 5 gigahertz channel. So tons of RF bandwidth. So likely you're still going to get your full speeds even at a half channel. But the advantage is now that you have up to 8 channels. So 4 channels is usually plenty, but there are cases where, like in the hub home, you have a hop, you have a link going to the home, that's 1 channel, and then you have another hop, that's another channel. And then you got our omni, which is 3 channels there, so you actually have 5 channels there. So you can see, and you can certainly have some links on full channel and some on half. You have the option. So just wanted to cover that. You'll see channel 4.5. So as we get further away from the oxygen absorption, we get better and better signal. So this is kind of a chart here showing for oxygen absorption, again, unique to 60 gigahertz. See, it's right centered at 60. And it's 16 dB per kilometer at 60. So your shorter links, if you're only going, let's say, a half a kilometer or less point to point, you may even want to purposely, for channel reuse reasons, you know, set it on channel 2. It just depends. There's some cases where, or if you're going 100 meters, set it on channel 2. It's fine. You're still negative 40 dBm or some super strong signal on the link on the other side. So it doesn't really matter. But for farther links, I definitely recommend using channel 4 or channel 4.5 even. If, like say in the US, you could use the higher frequency. It's up to about 67 gigahertz on the high side of this is the center frequency, so you go all the way up to 67, and it has much less attenuation. So people have been getting links further than 2 kilometers now with channel 4.5, and if you use the half channel, you're even a little further away, and you're just using a half channel, which has a little more, has like a 3 dB improvement in the SNR. So we've actually, there's a few people even got over 3 kilometers, but we don't really recommend it because there is more susceptible to, say, rain or something with that. But of course, with our radios, all of our 60 gigahertz radios, they have a built-in 5 gigahertz failover radio that runs in concurrent along with the 60. Okay, so let me cover now the Metrolink product line. So Metrolink is our 60 gigahertz product line. So there's the ML1, which is 1 gigabit throughput, has 5, like I said, all the radios that have a 5 gigahertz failover. That's, by the way, that's a 2x2, like an 866 megabits 5 gigahertz radio in there. So typically when it fails over, you'll still see typically a couple hundred megabits. It's still pretty good. So the ML1 has 1 gig ETH port, 1 SFP port. The ML 2.5, okay, so the difference, main thing I kind of highlighted between the ML1 and ML 2.5 is the speed, the performance. So same distance, okay, that's more determined by the output power and antenna gain, the distance in that regard, and they're going to have the same antenna or the same output power, the 14 dBm. So 2.5 gig ETH port, and there's also a higher, more powerful processor in the ML 2.5, so it'll actually handle more packets per second. So 2.5 gig ETH, they both have a single SFP port as well. Distance, people ask, we say up to about 1.6 kilometers or a mile using the 35 centimeter. That's the 42 dBi pointed at each other. You can go about, say a half a mile or about 1 kilometer on the 36 dBi or the 19 centimeter. So there's two variations of each model. There's the 19 centimeter and the 35 centimeter, the 36 dBi or the 42 dBi. Okay, now these were, let me go back. These are point-to-point or serving as the client device or subscriber unit back to a sector. So let me go now to our sectors. So there's two main sectors, and then we have our Omni I'll cover next, but the LW and the BF18. And just like kind of like the ML1 and ML 2.5, there is two variants. One is the 1 gig throughput, and the other is the 2.5 gig throughput. They're beamforming sectors at 18 dBi, 120 degree sectors. And the typical distance you can get with a client pointed, like the high gain client pointed back at it, is about up to 500 meters. People have gone further, but that's our recommended distance. And you'll have good, strong signal and performance with that. You can have up to 16 clients in that 120 degrees with the 2.4.1 firmware, which is recent firmware. Before that, it was 12 clients with the previous firmware. Okay, now there's the Omni. So the Omni is 3 of the BF18s in it. So it's like having the, and it has a SFP plus port. So you got 10 gig feeding into it if you want. So that's different too. So you got 3 120 degree sectors. They're 16 clients each. So a total of up to 48, 3 times 16, 48 total clients on the Omni. One thing to point out though, that if you have a lot of down tilt needs, like if you're mounting on a tower, you could have this pointed down pretty good with a lot of down tilt. Well, the Omni, keep that in mind though. If you're going to do an installation and it's really high up above the city or on a high tower, and you're going to overshoot, you may actually not want the Omni for that. But other than that, if it's pretty equal level, then you should be okay. The typical vertical beam width of the Omni, it's on the spec sheet, it's 32 degrees plus or minus 16 vertical, but from what I've seen in the field, it's more like about 10 to 20. 20 degrees plus or minus 10. So just keep that in mind in your installation. Also, I didn't mention earlier, but the 5 gigahertz radios on all these, you could set up a second virtual SSID for client access on these. Same with this, the 5 gigahertz failover radio can also serve as client access. And 2.4 gigahertz is client access only. So it's like, it is an access point. And back here, the ML1, even though you could say it's the lower model of the two, actually has 2.4 gigahertz access point in it, but it has no antenna though. So you have to run an external antenna, an omnidirectional with it. There's two RPSMA connectors on the ML1. That's on the case of the 19 centimeter or the 35. That's one thing the ML 2.5 doesn't have. Okay, this is the overview of the products I discussed. Okay, and moving on. This is point-to-point, point-to-multipoint products. Okay, this is showing the operating system, when you log into the radio. Real easy to use. I'd say the learning curve is pretty quick. It's not overwhelming. You could, and I had mentioned this, but all our radios, whether they be 60 gigahertz or Wi-Fi, they can all be managed locally on the UI with standalone. And a lot of people provision and set them up in standalone mode. And later on, if they decide to add it to the cloud and have it managed on the cloud, you can. So they can be standalone or cloud. Here's showing the local UI. You can see it's pretty simple. If you want to try out our products and you have any questions, feel free to reach out. You get a pair of, let's say, ML1s and want to set up a link and see some throughput you may have never seen before. So and you have any questions, definitely feel free to reach out to us. Okay, the bridging, as probably what you expect, but just want to point this out that it's layer 2 transparent bridging over the 60 and 5 gigahertz. So it's basically like running an Ethernet cable across the wire, wirelessly. So anything you're doing like VLANs or whatever is encapsulated, it's sent over wirelessly and then decapsulated on the other side. And whatever you're doing on one side is then maintained on the other side of the link. Okay, so the Omni comes with a mounting bracket, but the ML1, ML 2.5, the sectors, all those radios, you have to buy the bracket separately. So there's two brackets to choose from. There's the LR, and that's the long range precision. That's heavy duty bracket. Now, I definitely recommend that for any of the further links, or even if you're just using the 35 centimeter radio, because that's a 1 degree beam width. That's very narrow beam width, so it's not very forgiving when it comes to moving around back and forth with the wind, or even when you're installing it and you're trying to align it. It's nice and easy to adjust, fine-tuning vertical and horizontal. Now, the LC bracket is a lower cost alternative. I'd say that's still, and you can use it for the smaller 19s or all the sectors. You could certainly use it because it's 120 degrees anyway, so you can certainly go, the fact that it moves a little isn't really much of a problem. So if you haven't played around with 60, one thing you'll notice compared to say 5 is the beam widths are just so narrow. The 3 degrees on the 36 dBi, the 19 centimeter, and then the 1 degree. If you've ever first set up a link, it could be a little challenging. So we actually recommend, even if you have a ton of experience doing millimeter, the alignment scope is awesome. On all our radios, on the top you'll see a mounting boss for this scope, and it's actually a real gun scope in there. It has crosshairs and everything, and we highly recommend using it for doing point-to-point links, or even the point-to-multipoint with the client pointed back at the sector. It makes things so much easier and faster. And once you get the link established, then of course you then do your fine-tuning based on RSSI. You could do that in the local radios GUI, or you could use our link assist application. Now, on all the radios, there's a USB port. There's a USB port with a Bluetooth, so you can run a Bluetooth dongle, and you could use Android or Apple and download our app, and you could look at the signal strength that way when you're aligning the radio. Okay, so also now changing gears a little bit, we're going to talk about the IgniteNet switches. So IgniteNet actually carries 4 switches here. These are the say like the indoor versions, the standard, let's say traditional switches you'd expect. A layer 2 fully managed switch, PoE switch. There's the 8-port 24 and a fiber switch. So the 8-port PoE plus switch with 125 watt power budget. It's 8 Ethernet gig ports. and 2 SFP gig uplink ports. The 24 PoE is PoE plus on the 24 ports, 370 watt power budget, and 4 10 gig SFP uplink ports. And the fiber has 4 combos and 20 SFP ports and 4 SFP plus ports. We also have the Metrolink 5-port indoor and outdoor switch. This is kind of more of a unique product, I'd say. Just like we have the 60 gigahertz products, more niche. This is a niche product as well. It's indoor and outdoor, actually IP rated. And what's interesting, it has a DC in block. So you can feed DC in. You see there the blue block there in the picture. And if you feed it with DC in, you'll have PoE out on 4 of the ports. The PoE out could be the standard 82.3 AF AT or PoE passive PoE. Our radios like the ML1 and ML 2.5, those use its passive PoE. So you could use the output to power the radios out those ports with the DC in. That's kind of the purpose, and you see the pictures shown there in the bottom there where it's powering the radios. Also unique to it, it has this protocol Trill. So instead of using OSPF or other technologies, when you're creating a redundant link for let's say reliability, you're connecting the ring and you're allowing kind of connecting the, in a sense, purposely creating a loop. If you have, say, if you don't have any technology, then spanning tree protocol will kick in and cancel the link of one, and the failover would take some time, and you're not benefiting at all with, say, having the redundancy. Where with Trill, it'll allow for parallel links and connecting, and also be maintained and up. If you have more questions about the Metrolink Trill switch, definitely reach out to us. Okay, so I'm going to cover now the indoor and outdoor Wi-Fi products. We have a Spark AC 1200. It is an AC Wave 2 radio. It's indoor and outdoor. And you'll see at the price point it is an extremely aggressive price point for an indoor and outdoor standalone or cloud managed AP. It's 2x2, output power is 200 milliwatts, which is plenty. Actually, any higher than that, you'd have a problem. Your clients won't roam. So 2.4 and 5 gigahertz, and it just requires AF power to power. It's under 15 watts, so it's a 2x2. It's good for say hotel applications and like a normal use scenario, where we have also our Sunspot 2600, which is our higher performing model, which is more for higher density applications, like let's say a hotel lobby or a conference room or a concert venue. It's a 4x4 on both bands, 2.4 and 5 gigahertz. So it does require AT power to power it. Okay, now the Spark AC Wave 2s, minis. So there's 2 variants of the minis. They're really small. You look at the size there, 3.3 inch by about 1 inch. So it's really small, nice small form factor. It's perfect for MDU, dorms, assisted living, indoor applications where you may have even one per room or something like that. But even though they're really small, they're still, it is 11 AC Wave 2, high output power, 25 on 2.4 and 23 dBm on 5 gigahertz. So they actually can put out pretty good amount of power. The difference between the 2 I highlighted there in red is one is powered via a 5-volt 1 amp plug in the wall adapter, where the other is PoE, and it's PoE only. So I just want to clarify that. So you can't power it locally, or you just power it over Ethernet only, and that's our most popular one. Here's an overview of the products I just discussed. Okay, now moving on. Also, we have a gateway. So this is our cloud managed home SMB Wi-Fi gateway router. So one of the things I think a lot of people like using this is the fact that it can be, like all our other products, easily managed by the cloud. And so you could push and change configurations remotely. Okay, the G-Link Ethernet to coax converter. So G-Link, it's actually using G.hn technology. So it's converting Ethernet to coax like RG6 coax with an F connector like your TV. So what the big advantage of this is that you can now leverage existing, say, coax in a building. So to reduce costs or even time, and to get it into, say, rooms where it's difficult to run new cable, or just leverage the advantage of the fact that it's extremely long range, further, like Ethernet can only go 100 meters. So this is going to make a big difference. You can go up, it's not a typo, you can go up to 1+ kilometer, because it's 0 to 200 megahertz RF frequency. And that's a common question people say, what frequency, am I going to interfere? Most over the air is actually now above 200 megahertz. So you could actually coexist on the same line a lot of times. But so what you do is you have one master one, and typically that's our outdoor one there, the one on the left there in the picture, but it doesn't have to be. But then you could push up to 15 quote slave units where you could, and it could be going through splitters, and it says 1+ kilometer, but you're going to be splitting up the signal and running different into different rooms, and it's going to attenuate. So it's up to 15, and then there's no reason you couldn't just have another master again and daisy chain them over Cat5 or the Ethernet, the standard Ethernet, and then connect another master to 15 more, and you daisy chain them, and you keep going and going. Here's actually a slide here showing a little more detail. So let's say you have a building there, like a high rise, and you could have up to 15 there shown. Power, you could power these by the DC block on the master and feed power to the client radios, G-Links, I should say, and they'll, you don't even have to power them. It's kind of like power over Ethernet, but it's power over coax. So you can even run power to them. And also there's a reverse option too, where the indoor unit can backfeed power to the outdoor unit. And that's where it becomes sometimes popular, where the master, the outdoor, and this shown as the master, but it's the outdoor unit gets power to it from the indoor unit, and then the DC block on it actually becomes now power output that can now power like an ML1 there, like in the picture there, like one of our radios there, and feed power directly to the radio. So you could actually not need to run a power line out to the outside. Okay, next I'm going to cover the IgniteNet Cloud Controller. So as I mentioned, it's all the things I mentioned before. The indoor and outdoor Wi-Fi, our 60 gigahertz products, our wired access, that's our switches, are all managed by or can be managed by the cloud. And then, of course, the advantage of cloud is that you could be anywhere, anytime to access and to monitor, make changes. Okay, so I'd say it's pretty consistent what you expect from the cloud management software, where you'd have a site, your main cloud, your main account, and then you have sites, and then you have devices that are under the site. So here's just a visual. So say you have a hotel, and you could have 50 devices under that one hotel location. There's nothing stopping you from having multiple, say, sites in our cloud that could be physically the same location if you wanted to separate floor 1 and floor 2. Figure it's really for pushing configuration settings or monitoring purposes that you'd want to have separate sites. So let's say I did want to have a different SSID and passphrase pushed to different devices as a group. It's really just a group. So here's an overview of the cloud dashboard. So the dashboard is all your devices, everything under your sites, all sites. And what's good is then, from overview, you can quickly see, I see in this example, there's one offline. I want to dig and see what's wrong. So that would be good. Maybe proactively fix something. The site level. So now I went to a particular site. I have less units. I'm more drilling down. And when you go to a site, you could have a map overlay. You could upload, a floor, indoor floor plan, and drag and drop and put where the APs are. So for future troubleshooting or seeing where things are, let's say, in a year from now, you don't remember where you did the install, of course, in every AP. Of course, so let's say you get a complaint, the second floor, room 200 has bad Wi-Fi or something. Then you can just go to your map and then click on the AP and then drill down. In this example, you could see on the device dashboard all clients connected to it. This is an access point. You can see all the clients connected, who they are, what signal strength they are connected to, which is really useful. A lot of times you could find from that, the RSSI of the clients connected to the AP, if there's any coverage holes or if they're not roaming, or you have to say even the power's too high. That's a common problem in indoor Wi-Fi is power is too high, actually, and doesn't encourage the client devices to roam to the proper AP. Okay, and that concludes my presentation. I am now going to pass it over back to Julie.
Thank you, Dan, for that wonderful presentation. And it looks like I do got some questions for you. Let's get started with the first one. First question is, can you tell us how narrow you can set the beam?
Okay, I assume you're talking about the sector. And yes, it's adjustable. Here's the thing, though. Okay, so in the GUI, you'll see an option to change it from 120 down to 90 to 60 to 30 to 10. But here's the thing, it's beamforming anyway. And the beamforming actually narrows it down to 10 degrees all the time. So it's really, when you narrow it that way, it's really just how far it sweeps and scans across. So I actually recommend, once you're trying to mitigate interference or self-interference or noise, or say a reflective, say reducing multipath, just leave it 120 degrees. But you might see a slight increase in performance if you have, say, multipath or reflection or some interference off to the side, but you won't see actual signal strength improvement because it's already beamforming and down to 10 degrees per each client. And it actually has increments of 5 degrees, and there's 32 points. So it actually sweeps 160 degrees across, even though it's a 120 degree sector, 5-degree intervals. And then you'll actually see in the UI the sector position when you're connected. This is 2.4.1 firmware later. You'll actually see that value, like 55. What is that? That's 55 degrees from center. That's what it's currently using to talk to that client. And you'll see all the different clients connected to different connections. And then therefore anything above 60, you should be using a different sector, say if you're on an omni. So hopefully that wasn't too overwhelming, but if you want, I could certainly follow up with more offline if you want.
Thank you for that, Dan. Appreciate it. Next question here for you. Will we see a cross-comparison description for example, Ubiquity's new gigabit link with similar specs? It's
first I've heard of asking that. I think we can do that. Yeah. I'll ask the team about that.
Okay, excellent. Next question here for you. Does the estimation have the ability to measure terrain or any other levels of interference within the two links prior to installation?
Okay, so link path does not factor in any terrain. Now, there is an optional feature called Link Path Pro on the cloud. It's a paid service that does do that. It actually gets geographical space that you could load in and go to actual where you are on Earth, and then it'll factor in the actual terrain. So that's Link Path Pro. But just doing a calculation, that's just based on the channels of free space path loss, the rain attenuation and oxygen attenuation to get a signal. For a more advanced option that is Link Path Pro, that is in our cloud as an option, actually.
Thank you very much. Next question here for you. Are scopes always required to connect IgniteNet or Ignite links?
In my opinion, anything more than a half a kilometer, I would highly recommend it. You can do it, but you're going to spend a lot more time than you need. You might get lucky, or you're really good at it, or you've done a lot of installs. But even then, I just think it's just the best way to go is to get a scope. So I think I'll say I'll say yes to that. I'd say definitely if you're doing longer links, point-to-point links, especially. Figure a 1 degree beam, and you got two. So you're actually like, imagine you kind of got like two laser pointers, and they're both trying to look at each other until you start establishing any link in the first place. You'll get a link on 5 gigahertz, but the beam width on 5 gigahertz, is 10, 15 degrees or so. With our 35 centimeter, that's still a little too wide to really. You could get close, but in my opinion, I do recommend the scope. I do.
Thank you for that, Dan. Next question here for you. Outside of measuring rain, will it calculate throughput based on distance?
Yes. If you look at that there was 3 slides I had on the link path. The last one there before I skipped on was showing kind of estimated throughput based on distance. It's just the best guess estimated throughput based on the signal strength. So it is part of the link path tool. And like I said, it's just go ahead and go onto our cloud. It's free, and create a virtual link at say 1 kilometer, and you'll see the signal strength. You can base it on the rain if there's rain, and then you'll see an estimated throughput as well based on the distance and where you're at.
Excellent. Thank you, Dan. Next question here for you. Regarding link path, for future updates, will there be any updates to this, like a paid version, or will this always be free to use?
There's 2 variants of it. There is the basic version, which I showed, that you'll always be able to get an estimated signal strength based on, like I said, the main factors are the channel you're on, what frequency, which product you're using, of course, which in other words, how much dB gain there is. They're all put out the same output power, 14 dBm on 60 gigahertz, but some are 42 dBi, some are 36 dBi, some are 17 or 18 dBi, depending on which model you use. So that kind of determines your distance. So let's just say, so you choose the model, and you choose the channel you're on. You choose your range zone, and then and then your distance, and then that's basically it. Those are the main factors that would, because it does factor in. With 60, there's 3 things. There's free space path loss, there's rain, and there's 60 gigahertz oxygen absorption. So there's 3 things you have to factor in. So it does matter kind of what channel you're on. You'll notice in our link path, you go to channel 4.5, the signal will be better than channel 4 and channel 3, and channel 2 is the worst. So you'll actually see a slight. So that's good to factor that in when you do the calculation.
Thank you very much, Dan. Next question here for you. Does IgniteNet sell the Metrolink in packs, or do customers need to purchase them separately?
They're individual, although I'm not sure if you have any, if Microcom has any other ways of them packaging it, but we have them as individual. Okay,
thank you very much. A couple more questions here for you. I know.
That's a question for you guys. No, I'm kidding.
I know. We'll work on that. Does standalone need a computer running 24/7 to access the information?
No, you definitely, if it's standalone and you don't have it on the cloud, then of course you're going to have some way of getting into the unit, meaning, some sort of, port forwarding, or you have VPN or something, if you're remotely getting into it. I mean, that's the case with all standalone products that are in the industry. I would say that's pretty expected. One thing though, is, of course, if you're on the remote side and you have a a disconnection, then how do you get into it, to fix it, right? And that's where a 5 gigahertz failover is really good. So let's say the 60 goes down for whatever reason, there's a problem. At least you can get to it from 5 gigahertz. And here's the other thing I've seen people do is they'll screw up something on the 60 gigahertz setting. They'll change the SSID, or they'll change the channel, or do something. They'll lock themselves out of 60. But it's still accessible for the remote side, because The 5 gigahertz, as long as you set it up, will still fail over and connect on 5. It'll save you, and you'll still be able to get to that remote radio, still at least over the 5 gigahertz link, and then you can go ahead and make your fix.
Excellent. Thank you, Dan, for answering all of those questions for us this morning. And thank you to everyone for attending today's webinar. If anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown here today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Thank you, Dan, for your presentation again, and I appreciate everyone's attendance today. Have a wonderful day. Bye, everybody.